Good afternoon. Okay. So last time we were, ooh, that's way too zoomed in. Okay, last time we were talking about functions. And so we said that a function is, just like any other equation we might encounter, y equals something like 2x plus 3. The only difference with a function is that instead of calling y, we call it f of x. Because this names it as a function of x. In other words, this names it as we're putting something in for x and we're going to get something out. So for instance, if we plug in, well, I don't know, f of negative 2. What this means is that we're going to be putting negative 2 in for x. So we'll have 2 times, x is now negative 2, plus 3. And we go ahead and figure out what this represents. Of course, really what we have here now is just a expression that we need to simplify. So 2 times negative 2 is negative 4, and then negative 4 plus 3 is negative 1. So f of negative 2 is negative 1. And so in this way, what we now have is something that we can keep track of both what we plugged in and what we get out. So we plugged in negative 2, we got out negative 1. And functions come in all sorts of shapes and sizes. However, what actually goes into the structure of a function can determine quite a lot of different things. Now, I'm going to be using the calculator a lot today, so we're going to be zooming in on the screen of this thing so we can take a look at what these different pieces and parts can do. But before that, I want to give us something to think about. We can plug in anything we want for x into this equation, right? There's no domain. There's nothing that's going to make it break. and thus we should be able to get anything we want out for y. So, I said this last time, but if we think about the graph of this equation, this function, it's going to look something like this. There's not going to be any kind of weirdness going on here. It's not going to have any asymptotes, in other words, things that break the equation or break the function. And every single y value has an x value that goes along with it. So if we plug in an x here, it's going to give us out some kind of y. Now let's think about something real quick. Is there a time that I could change that up and plug something in for y and get out more than one x? I mean, if I make a function here real quick, maybe g of x equals x squared, and I plug in -2 for this, well, -2 squared is 4, positive 4, right? So that means that g of -2 is equal to positive 4. Now what happens if I do g of positive 2? Well, again, I get 2 squared, 2 to the second power. That means that g of positive 2 is also 4. So I can plug in two different x values and get the same y value, right? Okay. Can I plug in two different y values and get the same x value? Is that possible? Well, with a function, no. And this gets to what we call the vertical line test. Okay, so like with our graph here, if I pass a vertical line through this graph, so if I take this pencil to represent my vertical line, everywhere that it passes through the graph of my line is a single point. Okay? This thing never crosses twice. If we look at the graph of this one, in fact, this would be like this. So if I take my vertical line and pass it through here, does it ever pass through the graph more than once in any point? No. At any particular point, it's only passing through this graph in one place. It's not crossing it in two places. Now, what would happen if I took the inverse of this? Okay? So the inverse function. Remember that the way we get the inverse function is we change g of x into y, and then flip the position of y and x. And then solve for x. So to solve for x here, solve for y. So to solve for y here, we need to take the square root of both sides. So that means we have the square root of x equals y. So that's our new function. That's our inverse function. So what does this look like? Okay. So we got to think about it real quick. Again, it flips the positions of x's and y's. So what the graph of this one would look like is this. It has flipped this function over on its side, but there's something missing. Where's the other part of it? Where's the other half? Well, let's think about something real quick. Square roots. when we take the square root of a number, as long as it's positive, it's fine, right? But if it's negative, if we have a negative number in here, what kind of breaks? We have an asymptote, in other words. So this cannot cross this line. We can't go past here, and that's fine, okay? But where are the y's? Why is there not another section of y's here? It's because it would violate our vertical line test. So if I filled this other side back in, if I pass my vertical line through it, now it's passing more than one place. So we can restrict that. We can say, well, sure, x can't be negative. That's our domain. Oh, sorry, x cannot be don't know what I'm doing now. X must be greater than or equal to 0. So it can't cross this. It can't go into the negatives. But y also has to be greater than or equal to 0. Otherwise, we would violate that vertical line test. We would be getting more than one value that would give us more than one x value for each y. So keep that in mind as we're going through this. Vertical line tests. If we can pass a vertical line through our graph and it only crosses in one place at any given time, then it is a function. If it violates that, if it passes in more than one place at any given time, then it's not a function. So let's take a look at some functions. Again, we're going to be using the calculator to graph these because it's very fast and easy to do. Okay. So let's start off with a basic function. In fact, I've already got in here y equals x. There's nothing else in here. This is the most basic you can make a function, and if we graph this, this is what it looks like. So of course y equals x means that if y equals 1, x equals 1. If y equals 2, x equals 2, so on and so forth. So there's nothing modifying this. There's nothing that's making the x's and y's different. If we have an x, it's the same thing as y. Let's change that a little bit. Let's put another one in here to compare it to. Maybe x plus 1. Okay? Let's see what happens to this. So again, graph it. And it's the same line, but it's moved up. Well, what happened? If we go to our table here, this table shows us the first one, which again, y equals x. So any x value that we put in, so if we put in 0, the y equals 0. If we put in 1, the y equals 1. Put in 2, the y equals 2. For our other one, x plus 1, this one right here, if we put in an x, we add 1 to it. So 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. So it's all of our same values that we had before, all the same x's, but when we get our answer out for y, it's 1 more. It's because we added 1. In other words, what a plus does to this, if we add to x, it shifts our graph up. And stands to reason that then if we subtract something from x, that it would shift our graph down, just like we see here. What questions do we have? None? And if anybody in the stream has questions, of course, just type them and let me know. Okay, so let's back up a little bit. Let's try something else. Of course, we can add and subtract. What about multiply? So maybe we have 2x. Let's see what this does. Okay, so again, blue is our original. This is just y equals x. And then the red is our new one. So what has happened here? Well, again, if we go to our table, again, y equals x, so 0 equals 0. If we put in a 1 for x, we get a 1 for y. Over here, again, we are multiplying by 2. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6, so on and so forth. But if we look at our graph, what it's really doing is it is increasing the rate at which our graph increases. It's making it go steeper. Okay, well, maybe the way we get it to not be steep is if we divide. So let's do something like x divided by 2. Let's see what that does. And yeah, indeed, that's exactly what it does. If we do the opposite and divide, it makes the graph slope at a lower angle. So again, blue is our original. Red was x times 2, which makes it increase faster. Black is x divided by 2, which makes it decrease. I'm sorry, not decrease. It makes it increase slower. Okay, but all of these graphs are increasing. So the red is increasing, the blue is increasing, the black is increasing. My calculator's about to run out of battery. Oh no. So how do we get it to decrease? Well, we know that adding or subtracting just shifts the graph up or down. But multiplying changes how it increases, changes how it slopes. So we've got to multiply x by something. So, well, we know that multiplying by something makes it increase faster, dividing by something makes it increase slower. So what else could we change about what we're multiplying it by? Positives and negatives. So I'm going to put 2 times x back in here, and I'm going to compare it to negative 2 times x. Okay, graph it. And that's exactly what we can expect to see. So is our original graph. That's our y equals x. This was what we saw before, 2 times x, so increases the rate at which the graph is increasing. And then this right here is negative 2 times x. Now, if you notice, it is the same as this one, but in the opposite direction. In fact, if we delete that 2 and just make it negative x, again, it's the same as this one, just sloping in the opposite direction. So negatives cause the graph to change the way it's increasing or decreasing. Does that make sense? Okay. Any questions? All right, then let's get into something more complicated. So this time, where's my square? There it is. Let's try x squared. We already saw this one. Yeah, g of x equals x squared. We've already seen this one. So this is what the graph looks like. Okay. Let's try x squared plus 1. Same thing that we did with our previous really simple example. Again, it just shifts the graph up 1. X squared, whoops, not log, squared, minus 1 shifts the graph down 1. So same thing, still what we can expect to see. But what about if we multiply? Will it do the same thing? Okay, so I'm going to multiply this by negative 2 and this one by positive 2. see what we get. So there's our original, and then there's the second one. Ooh, interesting. So our original again is the blue. That's just x squared. The red is x squared times 2. Now, it kind of looks like it's increasing at the same rate. I mean, they're both going up in this direction, but it's thinner. That's because it actually is increasing the rate that that the graph increases. So if we look at like x is 1, well, think about it. If x is 1, we square 1, that's 1 times 2, it's 2. Compare that to the original. Each of these is multiplied by 2. Each of these values in our original has been multiplied by 2. So our y is increasing at a faster rate. Let me change this one to divide by 2. There we go. And so if we divide by 2, it's increasing at a slower rate now, just the same that we saw in the previous type of function. So it doesn't matter that one of them was just plain old x and the other one that we're looking at now is x squared. These still do the same thing. If we add something, it shifts the graph up or down. If we multiply or divide, it makes the graph increase or decrease faster. And if we, wrong one. If we use negative x squared, it inverts that graph. It makes it go the opposite direction. Instead of going down then up, it goes up then down. Just like our previous example, where it shifted the way that it was increasing, this is shifting the way that this one's going too. So now let's take a look at that last one we had. G of x is the square root of x. So we have second square root of x, graph that, and again, we have just this half. So where are our y values? Where are those negative y values? Well, if we plug in negative x values, oh, well, that's what happened to them. Of course, we cannot plug in a negative number into that square root. So us trying to get those negative y values, well, there's no possible way to get them. Is it possible to plug in something for x? So plug in something in the square root and get a negative number out? It is not possible. Okay? So that's why, if I compare this to x squared, this might be our original function, this might be our inverse function, okay? But just because an inverse takes something and flips the x's and y values doesn't mean that those new x and y values are going to be valid. So many times you might see somebody invert a function, and the way that the graph goes, it just goes and tilts 90 degrees. Because again, those y and x values have switched. Doesn't always work that way though. Sometimes, like with this one right here, those new values are not going to be valid. Any questions? All right. One more I want to look at. We've seen x divided by 2, but what if we have the other way around? 2 divided by x. Will that be the same? Well, before we do that, let's do something to compare it to. 1 over x. Ooh. Yeah, we got one of those things. So here, we have our x values. As they increase, y decreases. But then it gets to this point right here that it kind of jumps. But still, as x increases, y decreases. So we can say that for the entire thing, and that makes sense. When we did our divide by 2, it decreased how the graph was flowing, right? It decreased that slope. So this one's doing the same thing, but we got a weird thing going on here. What is this? We've talked about this before. This is an asymptote. So let's go ahead and look at that in here. X equals 0, we get an error. Well, that makes sense looking at this. If we plug in 0 for x, we have 1 divided by 0. Well, we can't divide by 0. So that's why we get this error here. It's just like with that square root of x. That value is not valid. Let's try 2 over x. Just changes the way that this increases and decreases. Any questions? Okay, and of course we can do all the other stuff to it too. So 1 over x plus 5, of course, just shifts the graph up 5 places. 1 over x times 2, same thing that we just had before, isn't it? It just increases the slope of the line. Okay, so these are the things that we can expect to see in any function. If we add to x or subtract from x, whoops, that's zoomed in, isn't it? If we add or subtract to x, then it will shift y, or shift our graph, up or down. If we multiply or divide x, it will increase or decrease y. And then lastly, if we invert our function, x and y switch. So these are the 3 things that we can expect to see when we're looking at functions. So now, when we look at something like this, y equals 2x plus 3, we can understand, okay, what's going on here is that we are increasing the rate at which this thing goes up, and then we're shifting it up 3. And that's true for any of these. If I were to add like plus 2 to the end of this one, it'd be the same as this, it would just shift it up 2. If I added minus 2 to the end of this one, it'd be the same thing as this, just shift it down 2. If I multiply it by 2, it's going to increase y by 2. So it'd be the same as this, it's just that the y values would be increased by 2. If I divide this by 2, it'd be the same as this, but the y values will be divided by 2. And so that increase or decrease rate is going to change. But again, it is the same for every function you might see out there. Anytime you see these things, they're going to do the same thing no matter what kind of function we have, whether it be linear or nonlinear. Any questions? Okay. So I think that will do it for today. My poor calculator needs to get plugged in real quick. So next week, Mr. Mrzinski is planning to have an exam, right? Saturday and Sunday of, wait, this week? Oh, well,
Wednesday, and Tuesday, and then he'll have it uploaded by tomorrow morning.
okay, so the exam is this weekend. Okay, for all of y'all on the stream, remember you have an exam this weekend. For some reason I thought it was next week. I was gonna have a review for that. If I'd known, I'd given it today. We'll figure something out, me and Mr. Mrzinski. How about that? Because I want to make sure that I get an exam for y'all as well over this stuff. Might get pushed to the final. Okay? But that'll do it for today. Just remember you have that exam. Get that exam in to Mr. Mrzinski. And I'll see y'all on Monday.
Yeah, the exam was pretty easy. The review was pretty easy. I don't think it'll be too challenging.
What did it go over? Out of curiosity.
It went over some absolute values, just like multiplying the outside numbers.
Yeah.
Just kind
Okay.
of basically. It went over a few a squared plus b squared c equals c, something like that.
Yeah,
It was a Wednesday, so I don't remember, but I think it was like the past 2 or 3 lessons that we did on hops.
yeah. Okay.
And like the variables and things like that.
Okay, thank you.